Okay, so please let me know whether you are able to hear me and you are able to see my screen.
First of all, good evening, sir.
Good evening. Yeah. Okay. Okay. So fine. So till now we have one second. So till now we have studied motion in one dimension, mm, motion in 1D, and we have also seen projectile motion in last two classes. Okay. So now we will start with relative motion. So So, what is the meaning of relative motion? Ideally, saying all the motion which we are seeing are relative to some other things. Like when we have seen the projectile motion, let's say this was the ground, and we have thrown some projectile at some velocity u. So when we say its velocity is u, its velocity is u, the value u is with respect to ground or something which is stationary on ground. So therefore we directly say the velocity is equal to u, and the velocity, basically it is the relative velocity of this object with respect to ground. But mm, now what we will see is when we will see the relative velocity between two objects which are moving at different velocity or at same speed with different direction. So this is how we'll see like how to find out relative velocity, and like how, and there are many other type of question which can be generated using these concepts. So let's say this is the point A. So and so this is, let's say this is x direction, and this is y direction, which is 90 degree, which is at 90 degree to the x axis, or it is y axis. So let's say object A is moving at velocity va towards x, and object B, let's say there is one more object which is object B, it is moving from same point, let's say, or maybe from other point, it is moving at velocity vb in y direction. Okay, so if we have to find out the relative velocity of b with respect to a, let's say, well, relative velocity of b with respect to a, it can be denoted as like the I have mentioned b slash a. So relative velocity of b with respect to a is given as vb, velocity of b minus velocity of a. So this will be the relative velocity of b with respect to a. In similar manner, if you have to find out relative velocity of a with respect to b, then we will write it as va minus vb. Okay, so now consider uh, like here is a and here is b. Now a is moving in x direction at, let's say this is a, this is b, object b. A is moving in x direction, let's say this is x direction with velocity 5 meter per second, and b is moving in x direction with velocity 10 meter per second. So the relative velocity of b with respect to a can be given as vb minus va. So it will be 10 minus 5, which is 5 meter per second. Similarly, if we have to find out relative velocity of A with respect to B, then it will be va minus vb, and therefore it will be 5 minus 10, so minus 5 meter per second. So here we can simply write vba is equal to 5 meter per second, and the direction of this is towards positive x, whereas the vab, velocity of a with respect to b, is also 5 meter per second, but its direction is opposite, or it is towards negative x-axis. So this was the example in like one dimension. Okay, we can also write, that like we have seen vectors, so we can write like if we have velocity, let's say, mm, let's say this is x coordinate of velocity, this is, let's say this is, okay, this is y-axis. So if there is a vector v which is a velocity, then x coordinate of velocity is given as vx, y coordinate is given as vy, and we can write this velocity vector as vx I plus vy j. Here vx is component of velocity in x direction, and vy is component of velocity in y direction. Similar manner, the I is basically unit vector in x direction, and j is unit vector in y direction. So if it is a three-dimensional space, then velocity, we can write velocity as v is equal to vxi plus vyj plus vzk. So here just one term got added, and here vz is velocity, component of velocity in z direction. Okay, and k is unit vector in z direction. So this is also important because in question they may give you like 3D velocity, like they will ask you to find out relative velocity in 3 dimensions. Okay, so now let's see few examples. So let's say this is x direction. Okay, and again velocity of object a is, let's say, 10 meter per second, and so it's in vector form. We can write this vector va, velocity a of a is as 10 I, where I is unit vector in x direction, 10 I meter per second. And let's say VB, it's, let's say we write it as 5 meter per second. So VB can be written as 5 I meter per second. Here we are writing I in both VA, VB because both are in x direction, and I is unit vector in x direction. So this is how we can represent the vector. So VAB can be written as VA minus VB. So it is equal to basically 5 I meter per second. So now let's move into 2 dimensions. So now let's say this is x and this is y. Okay. So now let's say A is moving at angle. This is, let's say, VA, velocity of A. Okay. This is velocity of A, which is moving at 37 degree to the x-axis. Okay. And let's say this was y. Okay. So, and there is a b which is moving at, and it is moving at 37 degree to the x-axis and moving at a velocity of, let's say, 10 meter per second. And uh, velocity of b, so velocity of b is, let's say, it is moving in positive x direction at 2 meter per second. So vb is, let's say, 2 meter per second. So in this case, you know that the what horizontal, like, component or component of velocity a in x direction can be given as va cos theta. So, and like va in x direction, and va in y direction here can be given as va sin theta. So you know that va is equal to 10 cos 37, because theta is 37 degree. Similarly, vertical component of velocity is 10 sin 37. So, so cos 37 is basically equal to zero point 0.8, and sin 37 is equal to zero point 0.6. You should remember these values. So for VAX will become equal to 8 meter per second, and VAY will become 6 meter per second. So in terms of vector representation, you can write it as velocity of VA is basically 8I plus 6J. And you know velocity of b, since it is only in positive x direction, there is no component of velocity b of like object b in y direction, so we can simply write it as 2I plus 0j, because there is no y component. So if we have to find out relative velocity of a with respect to b, then you can write it as va minus vb. So it will become 6I plus 6j. You know that you can subtract only ith component of I from other, like, only x component and y component separately. You cannot divide or subtract them in other way. Okay, so VAB is basically 6I plus 6j. So when let's, you know that, like, here we have VAB, relative velocity of A with respect to B is basically 6I plus 6j. So if we draw a vector, if you draw velocity vector, you know that it's this horizontal component is 6 and vertical component is also 6. So let's say we have this vector v a b, which is the velocity of a with respect to b, and both component are 6. So if they tell you to find out this angle theta, so you know that, like, sine theta is, or let's say tan theta, let's say tan theta is basically opposite side, which is a 6, divided by adjacent side, which is also 6, so you get 1. So therefore theta is equal to 45 degree. Okay, and second, they can ask you to find out the magnitude of this relative velocity. So you know that the magnitude can be given as, like, vab is basically is equal to square root of VAB in x direction, its square, and VAB in its y component square. This is from, basically, from Pythagoras theorem. You know that this adjacent side, you know that the opposite side, and you can easily find out the hypotenuse. So it will be square root of 6 square plus 6 square. So it will become square root of 36 plus 36, or you can simply write it as 6 root 2. Okay, because 36 plus 36 is basically 72. You can write 72 as 36 into 2. So 36, square root of 36 is 6, and square root 2 will remain as it is. So, so till now, do you have any problem in understanding relative velocity, or do you, like, want me to repeat anything? Do you have any question? Please write yes or no in chat box so I will understand. Okay, okay, fine. Okay, then I will move ahead. Just one second. So the question, whatever the question they will make, and those questions will not be based on only relative motion, but they will have, you will have to use concepts from motion in straight line and maybe from projectile motion also. So, and then they can frame the questions. Okay. So let's check one question. Okay. So let's say there is person A and person B. Okay. They are standing at distance of 300 meter from each other. So distance between A and B is 300 meter. This is person A, this is person B. The velocity of, if the velocity of person A, let's say if the velocity of person A is 20 meter per second towards, let's say this is X direction, towards X direction, and like VA is 20 meter per second, and velocity of B, basically VB, is let's say 30 meter per second, that too towards X direction. So if V person B is moving with 30 meter per second in X direction and person A is moving at 20 meter per second in X direction, then do you think they will meet at any point or any time? Is it possible? Can you write down yes or no? Like, is it possible that they will meet at some point? Mm, okay. So basically, like, let's say if VA, let's if VA is moving towards positive X direction at 20 meter per second. So after 1 second, it will move uh, 20 meter from the position, its position. Okay. Whereas VB will move uh, 30 meter from its initial position. So the distance between A and B will become 300 plus 30 minus 20. So it will become 310 meters after 1 second. If you see after 2 seconds, the A will travel 40 meters and B will travel 60 meters. So if now you find out the distance between them, it will be 300 plus 60 minus 40. So it will become 320 meter. So since VB is moving at higher velocity, the distance between A and B will keep on increasing in this case. Okay. But let's reverse the velocities. So you have A and here is a B. Okay. And again the distance or displacement between A and B, or shortest distance between A and B, is basically 300 meter. And you know VA is basically 30 meter in this case, 30 meter per second, and it is in positive X direction. And now VB is 20 meter per second. So Now in this case, if you see after 1 second, like if we have to find out distance between them, initially at t is equal to 0, it is 300. Now after 1 second, we a will travel distance into time. So when t is equal to 1, a will travel 30 meter. It a travels at 30 meter per second. So it will travel 30 meter towards x, positive x in 1 second. So let's say this is 30, where b will travel 20 meter uh, in 1 second. So if you find a distance, then it will become, so it will be like 20 in 1 second. It will b will move to this position, which is 20 meter away from this, and a will move to this location, which is 30 meter away. So the distance between them will become, so now you know that this, from this point to this point, distance was 300. Now A has traveled 30. So now this new location of A with initial position of B will be 300 minus 30 and plus 20 meters B has traveled. So it will become 290 meters. So since now the velocity of B is less than velocity of A and they are moving in same direction, VA will catch VB at some point. Okay. So they will ask you the question like, find out after what time they will catch each other, or at what distance from the initial position of A they will meet, or at what distance from initial position of B they will meet. So they can frame question in any manner. Okay. So now let's find out at what. So I will again write down the question. There is person A here and person B standing, or not standing, it is both are moving at 300 meters away from A. Okay. Now velocity of A is uh, 30 meter per second in this direction, and velocity of B is basically 20 meter per second. Now the question are, find time when A and B will meet, or they can ask, find time when A will cross B. Both are same questions. Okay. Find time when A will cross B. Second thing they will ask is, uh, at what distance from A, from initial position of A, from initial position of A, they will meet, or A will cross B. And similarly, they can ask at what distance from initial position of B they will meet, or A will cross B. So these kind of questions they can frame. So let's see. So you know that uh, like both of them will are moving at some velocity, initial velocity, like, and it is constant. Okay. So both, like A is moving at 30 meters per second, B is moving at 20 meters per second. So let's say T is the time. T is time when A will cross B, A will cross or catch B. Okay. So let's assume that. So let's find out how much distance A has traveled to catch B. So you know that S is equal to, for like, we know that earlier we have used constant, we have seen constant acceleration equations, but in this case there is no acceleration, velocity is constant. So since velocity is constant, we can simply write distance is basically velocity into time. So therefore, let's say S is the distance traveled by A to catch B. So S is equal to, or let's say, let's write down it as SA. Okay, SA is basically, here instead of U we write V. So here we write VA into T. So VA is 30 into T. So distance traveled by A to catch B is equal to 30 T. Okay. Now let's find out distance traveled by B. So SB is equal to VB into T. So SB is equal to 20T. Okay. SB we have found out equal to 20T. Now we know that A is like 300-meter behind B. So SA must be equal to, so okay. So first thing we got is SA is equal to 30T, and second thing we got is SB is equal to 20T. Now A was here moving at 30 meter per second, and B was here moving at 20 meter per second, and the distance between them are the uh, initial distance between them was 300 meters. Now let's see, let's consider that they met at this point. Okay, at some point, let's say this point is, let's say, point C. So this is the distance covered by A, whereas this is the distance covered by B. So this distance covered by A can be given as SA. Distance covered by B is given as SB. So you know that SA is basically SB plus 300. And now if we input the value of SA and SB, what we got above, from above solving above equation, we know that SA is 30T is equal to 20T plus 300. So therefore, after solving this, we get 10T is equal to 300. So T uh, is equal to 30 seconds. So basically, they will cross each other after 30 seconds, or they will, A will catch B after 30 seconds. So this is the first thing. Second, at what distance? So from initial position of A. So you know that both are having constant velocities. Okay. So in 30 seconds, let's say A is at this location. Initially, A is at this location. So after 30 seconds, it will move velocity VA into time. So that is basically distance covered by A from its initial position. So it will be 30 into 30. That will be 900 meters. In similar manner, SB has also traveled for 30 seconds, and velocity of B is 20 meter per second. So SB is basically equal to VB into T. So it can be given as 20 into 30. So that is 600 meters. So this was answer to this question. Mm, just give me 1 second. Till now, you have any doubt? Please write yes or no, so I will understand. Alka, if you are there, please write yes or no. So, do you have any question or doubt? Okay, fine. We'll move further. Yeah, if you have any question or doubt, you can just type, or if you are not having, you can just type. Like you don't have any doubt, so I can proceed further. ओके, नहीं मतलब बस मेरे को यही कहना है कि जो अभी बताया है उसमें अगर कुछ डाउट है तो यस और नो करके बता सकते हो, ताकि मैं रिपीट करूँगा, करना है या नहीं वो मेरे को पता चलेगा, इसीलिए मैं पूछता हूँ। ओके ओके फाइन ओके। सो you have seen that like uh okay, so in first question, when I wrote, like let's say when I given let's say this is A, this person is B. mm, so early in first question what I told is A is moving at 20 meter per seconds and B is moving at 30 meter per seconds. So what we found that in this case A will never catch B, and so let's find it out from relative motion concept. Okay, so distance between them was 300 meters, and let's say this is positive x direction, so velocity in this direction is positive. If velocity is in negative x direction, it will be negative. Okay, so if you stand at point A, then you will have to travel 300 meter in positive x direction to ca- catch B or to reach to B. Okay, if you are standing at A, you will have to move 300 meter towards positive x direction towards B, in positive x direction towards B. But now if we see the relative velocity of A with respect to B, relative velocity of A with respect to B is 20, like it, you know that it is VA minus VB. So it will be equal to 10 minus 20. So it is basically minus 10 meter per second. So minus 10 meter per second is basically telling you it is 10 meter per second in this direction, negative x direction. And for A to catch B, A has to move in positive x direction. So therefore, we can directly find out that A will never able to catch B because it is moving at 10 meter per second in negative direction relative to B. Okay. Whereas now again, take second example. It was A was moving at 30 meter per second in positive x direction, and let's say this is A, this is B, and B is moving at 20 meter per second in positive x direction, and the distance between A and B is 300 meters. So in this case also it is same thing, that A will have to travel 300 meters towards B to catch B. So if we find out relative velocity of A with respect to B, so in this case it will become thir- 30 minus 20, which is basically VA minus VB. So it is 30 minus 20, that is 10 meter per second. So it is 10 meter per second in positive x direction. So when we say relative velocity of A with respect to B, we assume that basically B is stationary. Okay. And A is what is velocity of A with respect to B. So relative velocity of A with respect to B here is 10 meter per second. So basically it is telling that when B is stationary, A is moving at 10 meter per second towards B. So the distance of A to B was 300 meters and velocity is 10. So you know that distance upon velocity is basically time. So time is equal to distance upon velocity or speed. So you can here it is 300 meters by relative velocity or relative speed is 10 meter per second. So it is basically equal to 30 seconds. Okay. So instead of solving from earlier method where we have found two different equations, we have found the value of t, we can simply use this relative velocity concept here to find out time taken by A to reach B or to catch B. Mm, okay, so you got like how we have solved it using relative velocity concept, the same question. You can solve using both method like conventional method or directly using relative velocity method. But make sure you use directions in proper manner. Just give me 1 second, okay? Okay, so we will see one question, one more question. So a train of 150-meter length, a train of 150-meter length is running towards east at speed of 10 meter per second. A parrot, or let's say a bird flies at speed of 5 meter per second towards west, parallel to the track, parallel to the track. The time taken by parrot to cross train is equal to. So find out time taken by bird to cross the train. Okay. So let's say like this is north, this is east, this is west, and this is south. Okay. So train is moving at train of 150-meter length is running towards east at speed of 10 meter per second, and a bird flies at speed of 5 meter per second towards west parallel to the track. Find out the time taken by bird to cross the train. Okay, so let's say we have a train. This is the length of a train, which is 150-meter. Okay, and this train is moving at 10 meter per second. Now there is a bird which is flying at 5 meter per second towards west parallel to the track. So let's say here is a bird which is a point. Okay, and it is moving at 5 meter per second towards west. You can see the direction here. This is west, this is east. Okay, and parallel to the track. So find out time taken by bird to cross. This is parallel to the track. Okay, so we have to find out time taken by bird to cross the train. So let's say at time t, or maybe I will draw it here. After time t, uh, you know that this total length is equal to 150-meter. Okay, you always draw the drawing, so it will be helpful. So it is train is moving at 10 meter per second. After time t, let's say the train has arrived at this location. Now this is the position of train, and bird has reached this point. So bird is still moving at 5 meter per second. Train is moving at 10 meter per second towards east. Bird is moving towards west. So after time t, bird has crossed, let's say, the train. So as you can see that, so if after time t, bird has crossed the train, let's say the distance travel, uh, this is, let's say, point A of a train, this is point B of a train. Again here the point A is here, point B is here. So distance traveled by point A of a train is, let's say, it is x. Okay, so this distance is basically, which is distance traveled by bird, can be, since the total length was 150-meter earlier, we can simply write this as 150 minus x. Okay, so this x is basically distance traveled by point A of a train. So we know the velocity of point A. So it was 10 meter per second. So if you have to find out, like, x distance is equal to speed or velocity is basically 10 here into time is t. So x is equal to 10t. Now similarly for bird, we know that bird has traveled 150 minus x, distance equal to 150 minus x in time t. So 150 minus x is equal to velocity into time. So it is 5t. So 150. So we got two equations. First is x equal to 10t. Second is 150 minus x is 5t. So here we will put equation number 1 into equation number 2. So what we will put, x is equal to 10t. So what we will get here, 150 minus 10t is equal to 5t. So that will give us 15t is equal to 150. Therefore, time t is equal to 10 seconds. So time taken by bird to cross the train is basically equal to 10 seconds. So this is from our conventional method where we find out the location and we solve two parallel simultaneous equations. Whereas if now we found out relative velocity of, let's find out relative velocity of train. So let's say t as a train with respect to b as a bird. So it is equal to velocity of train minus velocity of bird. So it is equal to 10. And now you can see that, let's this is positive x direction. So velocity in positive x direction is positive, whereas velocity in negative x direction is negative. So 5 minus, so VB is here basically minus 5 because it is in negative x direction. So velocity of train with respect to bird is, relative velocity of train with respect to bird is 15 meter per second. And when we say relative velocity of train with respect to bird, now so this is velocity of train when bird is stationary. So if bird is stationary, the train will have to travel by 150 meter to cross bird. So again, we know that distance is equal to speed upon time, or displacement is velocity into time, or distance is basically speed into time. So here we can write distance as 150 is equal to, uh, here with relative velocity we have 15 into time. So time is again equal to 10 seconds. So in both way we can find out the time taken by bird to cross the train, or both are true, right? Whether it is time taken by bird to cross train, or time taken by train to cross bird. Any questions? Can I proceed, or please write yes or no so I can go to the next question. Okay. So the next question is, two train 150-meter long, two train 150-meter long are traveling in opposite direction with respective velocity 10 meter per second and 15 meter per second. So find out time of crossing. Find out time of crossing. Okay, so both the train are 150-meter length. Okay, so let's say this is a train A, or okay, let's we have train T1. Okay, train T1, and we have train T2. Let's say train T1 is moving at 10 meter per second towards, let's define it, this is, let's say, positive x direction, this is negative x direction. Okay, so train T1 is moving at 10 meter per second towards positive x direction, and since both are moving in opposite direction, so the T2 is moving at 15 meter per second in negative x direction. Okay, so let's A is the initial point, like A to B are the point, and let's say DC or CD. That's right. It has a CD is train 2. So B is the mm what B is the first point, or it is the uh, rightmost point of train T1, and here C is basically leftmost point of train T2. So since both train are 150-meter length, so this is 150-meter. A to B is basically 150-meter. Similarly, C to D is also 150-meter. So let's again draw vertical lines. So when they will cross each other, what it does it mean is, like, if this is train AB, and so final position will be, they will cross each other means final position of, like, A and B, when A and D are matching, this is the point of crossing. And since this is this CD is moving in towards negative direction of x with 15 meter per second, AB is moving at 10 meter per second towards positive x direction, and A and D are basically crossing. Like, this is how we say, like, when two trains have crossed completely, so this will be their final position. So let's consider after time t, both the trains have crossed each other. Okay. So after time t, this is the position of, let's say, train AB or train T1. And let's say this is the position of train CD or train T2. So now let's consider, that this total length is 150 plus 150. This total length is 300 meters from earlier information, whatever we have. So now let's consider that train CD has traveled by distance x in time t. So when CD has traveled by distance x, so AB has, if you see the distance traveled by AB, it is 300 minus x. So we know that distance, let's say for train T1, for train T1 or train AB, distance, which is basically 300 minus x, equal to velocity into time. So velocity here is 10 meter per second. Let's say 10 into time is t. Now for train T2, distance T2 or train CD, distance traveled is x. So it is equal to velocity, which is 15 into time t. So let's say this is equation 1, this is equation 2. So now if we put equation number 2, which is x equal to 15t, into equation number 1, we will get 300 minus 15t is equal to 10t. So finally we get 25 times time, or t is equal to 300. So t is equal to 12 seconds. Now coming to the method of relative motion. So this is train T1, which is also given as AB, and its length is 150 meter. Then we have train CD, which is also 150 meter. Train of AB is 10 meter per seconds. Sorry, velocity of AB is 10 meter per second, and velocity of CD is 15 meter per second in negative x direction. This is in positive x direction. So we can simply write velocity of t1. Since we are considering velocity in x direction, positive x direction as positive, velocity of t1 is as 10 meter per second, whereas CD is t2. So velocity t2 is equal to minus 15 meter per second. So relative velocity of train t1 with respect to t2. So relative velocity of t1 with respect to t2 is given as v t1 minus v t2. So it will be equal to 10 minus 15. So we get 25 meter per second. So velocity, like relative velocity of t1 with respect to t2 means we are keeping t2 stationary and finding velocity of a with respect to or velocity of t1 with respect to t2. So when both train are crossing, let's say now CD is stationary. So or when T2 is stationary, let's consider T2 is stationary. So we will say the train T1 has crossed T2 when final position will become like this point A will reach point D. Okay. So then only we will say train T1 has crossed T2. So to so the distance traveled by point A on train T1 is basically 150 meter, which is its initial length, and then 150 meter, which is the length of train T2. So it is equal to 300 meters. So 300 is basically distance into velocity is equal to velocity into time. So velocity, of course, we got relative velocity as 25. So time is equal to 300 by 25. Again, it is equal to 12 seconds. So no matter which method you use, you will get same answers. So, okay. Any question? Okay, fine. So I will give one question to both of you. Please try this question with, I will give you 2 minutes to solve this question. Okay. A police car moving with 10 meter per second east. A police car moving with 10 meter per second east is following a thief car which is moving at 5 meter per second. Okay. If distance between them is 50 meter, after how much time police will catch thief? Is 50 meters. After how much time police will catch thief? So there is a police car, let's say we write it as P, which is moving towards east at 10 meter per second. And there is thief car, let's write down as a T, which is moving it is also moving towards east at 5 meter per second, and the distance between them is 50 meter. So tell how, after how many seconds or maybe minutes the police will catch thief. So so please try this question. I will give you 2 minutes to solve. Otherwise, I will give the answer. Okay. Please try to solve this. Okay, you got the answer as 10 seconds. Alka, are you trying? Still trying? Or you have also
सर मेरा आंसर भी 10 सेकेंड ही आया है.
10 seconds? Okay, fine.
यस सर.
Okay. So if we see the relative velocity method, so we know that the velocity of P, that is police, is basically 10 meter per second, and velocity of thieves is Vt is equal to 5 meter per second. So relative velocity of police with respect to thieves, that is Vpt, is given as Vp minus Vt. So it is equal to 10 minus 5, it is equal to 5 meter per second. So Vpt, so when we are saying relative velocity, we are considering t is not moving. So basically now the police has to move 50 meter, so distance is 50 upon its velocity is 5. So we got time is equal to 10 seconds. So both of you got correct answer. So we'll see one more question. So Two cars are moving towards each other with velocities. Two cars are moving towards each other with velocities 50 meter per second and 30 meter per second. With velocities 50 meter per second and 30 meter per second. And both are at distance of at are at distance of 320 meters from each other. So after how much time they will meet? So again, you know that there is car one, let's say this is car one, it is moving at velocity of 50 meter per second, and since they are moving towards each other, there is car two which is moving at 30 meter per second. Okay, now the distance between them is given as, let's say, 320 meter. So we will simply use the relative like velocity method, where the relative velocity of car 1 with respect to car 2 is v1 minus v2. So it is equal to 50 minus 30. Minus 30 because this is in negative direction of x, or this 50 was in positive direction of x. So we got relative velocity of 1 with respect to 2 as 80 meter per second. So time is equal to distance upon speed. So distance was like 320, speed was 80. So we got 4 seconds. So after 4 seconds, those two cars will meet each other. Okay. So I think this was also similar question only. We'll see a few more question and then we'll shift to the like boat and river things. So so a train moved in north direction. A train moved in north direction with speed of 15 meter per second. With speed of 15 meter per seconds, and a monkey is running on roof of a train. A monkey is moving on roof of a train along in the direction like in same direction of train at 5 meter per seconds. 5 meter per seconds with respect to train. So another train going with 10 meter per second is coming from opposite side. Okay. Now we have another train going with 10 meter per second, going with 10 meter per second coming from opposite side, is coming from opposite side. What will be the velocity of monkey as observed by observer in another train? What will be the velocity of monkey as observed by observer in another train? Okay, so train is moving at 15 meter per second. Monkey is moving in the direction of train and at velocity of 5 meter per second with respect to train. Okay, so let's say this is a train. Let's say this is a train AB. This train is moving at velocity of 15 meter per second. Let's say it's in some direction. Let's say in positive x direction. Now monkey, let's consider this M is a monkey, and monkey is moving at 5 meter per second with respect to train. So this, let's say AB is a train, T, let's say T as a train. So M is a monkey. So relative velocity of monkey with respect to train is 5 meter per second in the direction of train. Okay, it is given. So you know that Vm T slash T is basically equal to Vm minus Vt. So the velocity of monkey is not known. Velocity of train is 15 meter per second. Relative velocity of is 5. So velocity of monkey is basically, absolute velocity of monkey is basically 20 meter per second in x direction. Okay, positive x direction. Now there is one train which is coming from opposite side at 10 meter per second. Let's say this is T2. So if we have to find out, so we have to find out basically velocity of monkey as observed from observer in another train. So basically there is some observer sitting here in another train. So since train is moving at 10 meter per second, that observer is also moving at 10 meter per second in negative x direction. So the velocity of monkey observed by observer, so it will be basically relative velocity of monkey with respect to train. So that can be given as relative velocity of monkey with train T2. So it is equal to Vm minus Vt2. So Vm here is 20 meter per second minus, since this train 2 is moving in negative x direction, it is velocity will become minus 10. So we will get it as 30 meter per second. So this is the final answer. Okay, any doubt till now?
No, sir.
Okay, Vaibhav. Okay, so fine. So now we'll start with the boat and river problem. So we'll take around 13-14 minutes break. We will meet at 6:30. Okay. 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 So we'll meet at 6:30. Vaibhav, are you there? Okay, so we will start again. So we will see the river and boat problem because it is very common in these relative motion questions. Like they ask, they can ask a question from river and boat problem, from river and boat problem. Okay, okay. So okay, so let's say uh, let's say this is a ground and river is flowing. Uh, okay, and this is the direction of flow. Okay, so this is the direction in which a river is flowing. Okay, so if you are like looking at this position, let's say you are looking at point A. So let's say you are at point A. So from your location, whatever region is there in the direction of flow. So you know that this is the direction of flow. So from your location, is the uh, whatever is this region in the direction of flow, this region is basically known as downstream. Okay. Whereas if you see the region which is like towards uh, so this region is basically, since this is the direction of flow from your location, this region is on left hand side, which is on opposite to the direction of flow. So this region is basically known as upstream region. Okay. So again I will tell you, like if you are at this location, let's say this is your position, let's say this is your position. So if you move in the direction, if you move in the direction of flow, which is this direction, so this region is basically known as downstream region. Whereas if you move opposite to the direction of flow, since direction of flow is this, if you move opposite to direction of flow, the remaining region is basically known as upstream region. Okay. So again we'll see. So this is the river flowing, and now this is, let's say this, there is one boat here. Okay. So if river is flowing in this direction, let's say this is positive x direction, this is negative x direction. Negative x, this is positive x. So if river is flowing in positive x direction, and let's say this boat is also flowing in positive x direction, then we will say this boat is moving downstream. Boat is moving downstream. So when we are saying boat is moving downstream, the velocity direction of the boat and the direction of the flow of river is same. Okay. Direction of boat and direction of river flow are same. Whereas now again you have a river. You know that this is positive x direction, this is negative x direction. So again the river is flowing in this direction. Okay. Whereas this time the boat is flowing in opposite direction to the river, then we will say boat is moving upstream. So when we will say boat is moving upstream, direction of boat is opposite to direction of river flow. So okay, till now any question? Like you understand? Have you understood like what is downstream and what is upstream? Okay, okay, fine. So we will see one general case. Okay, let's say again we have a river. So the water in this river is moving at velocity VR. Okay, and now if you have a boat, if this boat, let's say velocity of this boat is VB. So, well, let's say this boat is moving in downstream direction. Okay. So, the in this case, the relative velocity of boat with respect to river can be given as VB minus VR. Similarly, if the VB is like boat is moving in upstream direction, let's say. So in this case, VB minus, okay, you know that like how we give relative velocity. So we'll move on to the question and we'll see the required concept during questions only. I think that will be much better. So let's say a boat covers 10 kilometer upstream in 5 hours. Okay. A boat covers 10 kilometer upstream in 5 hours and 10 kilometer downstream in 2 hours and 10 kilometer downstream in 2 hours. So find speed of boat and river. Question is find speed of boat and river. So again they have given us two cases. First case is let's say VR is the velocity of river and we have a boat. The boat is moving upstream. So VB is the velocity of the boat. Okay. So now you know that like when both are moving in opposite direction, like when so Okay. Okay, fine. So now you see, like if you have a lake, okay. Now there is a lake. So in this lake, if there is a boat at, let's say, point A, and let's it goes to point B. So you know that the water in lake is stationary, or it is not moving. Okay. So whatever the velocity at which the boat is going from A to B is the velocity of boat only. And here the velocity of flow or water is zero. So therefore the whatever velocity we have is velocity of boat. Whereas if you see one case, now river is flowing in positive x direction, boat is also flowing in positive x direction. So this is positive x direction, and velocity of boat is vb, and velocity of river is vr. So in this case, like if we have to cover some distance d, okay, so time required will become, see, if Vr is equal to 0, okay, if velocity of river is 0, if it is stationary, then time required will be distance upon velocity of boat. But in this case, boat has its velocity, boat has its absolute velocity. Apart from that, river is also helping boat to move in this direction, because river is also having some, if river is also having some velocity. So when boat, if now if we consider case where river is having some velocity, okay, it is not zero, it is some positive value, and when boat is moving downstream, so in this case the time required will be distance upon velocity of boat plus velocity of river. So both of the terms will get added. It is like, consider like you have a road. Let's say you have a road. Okay, there is a vehicle A which is moving at 5 meter per seconds, and you have to cover distance of 50 meters. So you know that in this case, time required to travel this 50 meter will be, let's say you have to travel this from this point C to point D. So in this case, you have to travel distance which is 50, sorry, it is 50 distance, 50 meter divided by velocity 5. That is, you will have to travel for 10 seconds, then you will cross this 50-meter distance. But now consider a case where this vehicle is moving at 5 meter per second, and this road is also moving at 5 meter per second. So to cover this 50 meter, so now both vehicle and road are moving in this case, let's say. So in this case, the time required will be 50 upon velocity of vehicle plus velocity of road, that will become 5 seconds. So if you miss, most of you go to the malls, right? In malls, you find escalators. So on escalators, like if, let's say this is ground floor, this is first floor, okay, and you are going by escalators, so when you just step in on any let's say any stair, and you don't move, in this case the time required for you to cover this height will depend on the speed of this escalator, okay. But in some cases, when you step in, you start moving by yourself also, and therefore the time taken by you to reach the first floor is less in that case, and that is because the total velocity Earlier it is velocity of escalators, okay, but when you start walking or climbing these steps also along with the motion of escalators, it will become velocity of your your motion plus velocity of escalator, so it gets added. So the time required in this case is therefore lesser. So this is how, when you are moving in the direction of river, or when you are moving in downstream direction, then the velocities of boat and velocity of river get added. So if we have to find the time taken, it will become basically distance upon velocity of both plus velocity of river. So this is for downstream case. Whereas if you are moving in opposite direction of the river, then the time required will be distance upon velocity of boat minus velocity of river, because now river is creating resistance for your motion. So it is like moving on like opposite escalator. Like this escalator is basically used for climbing up, but now you started from here at some velocity. So of course you will have to like you will have to put more effort to come down, because that escalator is moving in opposite direction. Or let's say this was the road, this is the vehicle. So now if vehicle is moving at 5 meter per second and this road is moving in opposite direction at 2 meter per second, so your net velocity will become 3 meter per second in this direction. Okay. So so it is basically, if you see it properly, it is just like you have to find out net velocity. So when uh, going downstream, it is basically okay. When going, like, if both are going in same direction, it will get added up net velocity. And if you are both, like, boat and river are going in opposite direction, that is for upstream case, uh, they will get subtracted. So the question here is, a boat covers 10 kilometer upstream in 5 hours. So when it is moving upstream, so upstream means boat is moving in the direction opposite to the flow. So this is the direction of river, that with velocity vr, and velocity of boat is vb. So it covers 10 kilometer distance in 5 hours. So you know that this is basically vb minus vr. So since we know that distance is basically uh, speed into time, or you can say uh, you can simply write time taken by is given as distance upon speed. So in this case, therefore, you can write vb minus vr is basically equal to distance, which is 10 kilometer, divided by number of hours, that is 5. So you get it equal to 2 kilometer per hour. So you get vb minus vr is equal to 2 kilometer per hour. Whereas in second case of downstream case, the boat is covering 10 kilometer in 2 hours. So you know that in downstream case, net velocity is given as vb plus vr. So therefore vb plus vr is basically here distance upon time. So it is 5 kilometer per hour. So now you have two equations. First one is vb plus vr is equal to 5, and vb minus vr is equal to 2. Okay. So from that, like, if you add these two equation, you will get 2 vb is equal to 7. vr will get cancelled. So vb is equal to 3.5 kilometer per hour. And if you put this value of vb in any one of these equation, you will find out vr is equal to 1.5 kilometer per hour. So you should notice the like the net velocity in downstream case is velocity of boat plus velocity of river. In upstream case, it is velocity of boat minus velocity of river. Okay. And if you are going upstream, so if you are going downstream, let's say first you go downstream. So this is boat is going downstream. So downstream means in the direction of flow. Let's say this is VR, velocity of river, this is VB, velocity of boat. So in this case, of course, the boat will always go in this direction only. Whereas if you are going upstream, okay, like upstream is if you are trying to go upstream basically. So of course the reverse direction will remain same. But if the velocity of boat is in this direction, VB. So there are two possibilities. Like if VB minus VR, if it is positive, then boat will go upstream. It will all, but if VB minus VR is coming negative, so that means the velocity of boat is not enough to overcome the resistance of river, and that means your boat will move in downstream direction only. So this thing you should notice, or you should able to identify. So any question or any doubt? Yes, I will give a question. I will take more questions. That is not a problem. Okay, so let's see the next question. Uh, a boat travels 1 kilometer per hour in still water. It takes 10 hours to move upstream a distance of 5 kilometers. 10 hours to move upstream a distance of 5 kilometers. So find speed of river. So when it is given like a boat travels in a still water, so you whenever you will see the speed of boat in still water, that is telling us the actual speed of boat. Okay, so here we can write velocity of boat here is equal to 1 kilometer per hour. So it is basically telling us the speed of mm, speed of boat. So when the river is not moving, or if it is in a lake, okay, so it is the speed of boat. So that you should always remember when you will find the term still water, you should know that it is velocity of boat they have given. So it takes 10 hours to move upstream. Okay, so we have seen earlier, we'll see once again. So if so we know that we have seen two cases. First one, this is a boat which is moving at velocity VB. Then there is a river which is moving at velocity VR. So when when boat and river are moving in same direction, we know that it is moving in downstream direction. In this case, net velocity is basically net velocity of boat will be VB plus VR. So if we have to find out time taken by this boat to travel some distance, it will be d by v net, which is VB plus VR. On the other hand, we have seen uh, case where boat is moving in opposite direction to the river. So let's say this is a river which is flowing at velocity VR. So in this case, boat is moving opposite to the direction of river. So we called it as upstream case. And in this case, net velocity will be velocity of boat minus velocity of a river, and it will be in the direction opposite to the direction of river. So in this case, if you have to find time, then it will be distance upon VB minus VR. So now they have given us a case where boat travels at 1 kilometer per hour in still water. So still water here telling us that this is the absolute velocity of boat. Okay. So they have given absolute velocity of boat as 1 kilometer per hour. So, and they have also given us it boat takes 10 hours to move upstream a distance of 5 kilometer. So it takes 10 hours. Time basically 10 hours is given to travel distance 5 kilometer in upstream. So since it is upstream case, it is VB minus VR. So VB is already known, that is 1 kilometer per hour. Okay. So we just have to find out VR. So if we bring this on this side, and if we bring 10 into denominator, what we will get is 1 minus VR is basically 5 upon 10, that is equal to 0.5. So now therefore from this we will get VR is equal to 0.5 kilometer per hour. So this is the velocity of river, 0.5 kilometer per hour. So do you have any question in this problem? Okay, just give me 1 minute. Okay, I'm getting some important call. 1 or 2 minutes, I will come back. Just give me 1 or 2 minutes. Okay, so we will move on to the next question. And okay, I will give a question. You just try it for 1 or 2 minutes. That will be, I think, better thing. So I will understand whether you are getting this or not. So a boat a boat travels at speed of 4 kilometer per hour in still water. If the speed of river is 2 kilometer per hour, find the time taken by boat to cover a distance of 12 kilometers upstream and downstream. Okay, so this is not that difficult question. So I will give you 2 minutes to solve this and then I will answer it. So please try to answer it within 2 minutes.
The answer is 8, I think.
Like you have to find out for upstream and downstream. So there will be two answers. Okay. So you have to find out basically
ओके
time.
सर तो
Okay, time
सर
taken.
अपस्ट्रीम के लिए 6 आवर और डाउनस्ट्रीम के लिए 8 आवर.
Okay.
नहीं नहीं आई थिंक हाँ यही है सर.
Okay. Vaibhav, any answer from your side? Okay, okay, fine. Please do it fast. So, so we can move on to the next questions. Okay, I think, yeah, I think for upstream it should be 6, and for downstream, see, in whenever there is a downstream motion, like when boat is moving in the direction of river, it will cover distance quickly. So you should always notice that, like, time taken by boat to travel same distance in downstream direction will be lesser compared to in upstream direction. Okay, so here the first they have given a boat travels at speed of 4 km/h in still water. So that means it is the velocity of boat which is directly given, which is in still water. It is 4 km/h. And if the speed of the river is 2 km/h, so they have also given the speed of the river. So net velocity of boat, like if you go in downstream direction, means in the direction of river, it will be VB plus VR. Let's say Vn, we write it as Vn as net velocity. So it will be 4 plus 2, that means 6 km/h. Okay. Whereas net velocity, so this was downstream case when both are moving in same direction. But when the boat is moving upstream to the direction of river, so Vn will be basically net velocity will be Vb minus Vr. So it will be 4 minus 2, so it will be 2 km/h. Okay. So now you have to find time. So you know that time is basically distance upon velocity. So here velocity is Vn, which is net velocity. Same for upstream case also. So distance is given as 12 kilometers. Then Vn is 6 kilometers. So time is basically 2 hours. So 2 hours for downstream case. Whereas for upstream case, distance is same, which is 12 kilometer. Whereas net velocity is 2 km/h. So whatever time is 6 hours. So for upstream case, time is 6 hours. For downstream case, time is 2 hours. Okay. So let's see the next question. So okay. So until now, whatever we have seen, like we have seen the example of river and boat, river and boat, or we have seen train crossing. So all of these motions were in one dimension only. Either means it was in x direction, whether it is positive x or negative x, but it was in x direction. But now we'll see some example with relative motion in basically two directions. So earlier we have, like at the starting of this class, we have seen like when there are two uh, velocities are in two dimensions, we can divide the given velocity. Let's say we have velocity 10, let's say, which is making angle 30 degree with horizontal. We can divide this velocity in x component and y component. So it will be 10 sine 30. This will be 10 cos 30. And then we can basically solve these questions. So now let's see a case, or let's see directly, let's move on to the question. So rain was falling vertically with speed 40 meter per second, and a person A was running with 30 meter per second. Now let's say person A was running with 30 meter per second. So relative velocity let's find relative velocity of rain with respect to a. Okay, so find out relative velocity of a with or of rain with respect to a. So now in this case, you know that like if this is the ground and there is a person which is moving at velocity of 30 meter per second, and there is a rain which is falling at velocity of 40 meter per second. So if we have to find out, let's say relative velocity of rain with respect to uh, relative velocity of rain with respect to that person A. So this was person A. This is for rain. So first thing you can do is you can divide this problem into x and y axis. So horizontal is x, vertical is y. Okay. Let's say this upward is positive y and this right side is positive x. Okay. So from this we can see that rain is moving downward at 40 meter per second. So for rain, let's say Vr is a velocity of rain. So you can write it as, you know that unit vector in x direction is I, unit vector in y direction is j. So you can simply write this as minus 40 j because it is in y direction and that is also downward direction. So it is minus 40 j. Whereas velocity of person A can simply be written as 30 I because he is moving in positive x direction. So relative velocity of rain with respect to person A is given as Vr minus Va. So it will be Vr is basically minus 40j and minus Va is 30i. So it is finally you will get is minus 30i minus 40j. So this is basically the relative velocity of rain drop with respect to person A. Okay. Now, if we have to find out the magnitude, you know that like if there is a velocity which is written as Vxi plus Vyj, where Vx is velocity component in x direction, Vy is velocity component in y direction, then the magnitude of this velocity can be given as Vx square root of Vx square plus Vy square from Pythagoras theorem basically. Therefore, if we have to find out the magnitude of velocity of rain with respect to velocity of that person A, then you can simply write it down as square root of minus 30 square plus square root of plus minus 40 square. So that will basically give you square root of 2500 and you will get it equal to 50 meter per second. So this is the relative velocity of raindrop with respect to person A, which is 50 meter per second. So mm, any doubt in this 2D kind of problem? Okay. So we will move on to the next question, which is also of similar kind, only the final answer, whatever they have asked, is different. Okay, so rain was falling vertically. Rain was falling vertically. A starts running with velocity. Okay, now person A starts running. Velocity of rain with respect to A is 10 meter per second. Velocity of rain with respect to A is 10 meter per second at angle 45 degree. So what will be the speed of A? So what will be the speed of A and rain? Okay, and rain. So I think this is slightly tricky question. So I will give you 2 minutes to solve this question. If you are not able to solve it, then I will give you the answer. Okay. So please try to solve this question. You have 2 minutes. Okay, I think I will answer this question. It is slightly tricky. So what whenever we did this question, no. So here we have seen in this triangle, rain was falling at 40 then this person was moving at 30 meter per second, and therefore their relative motion, whatever we got, it was 50, and it was uh okay, just give me one more second, just give me 1 second, okay. Okay, I'm sorry, actually I was getting one call for delivery. Okay, so this was the uh okay, so this was the velocity of rain, it was 40. The velocity of person was 30, and therefore we got their relative velocity as a 50, which is square root of 40 square plus 30 square from the Pythagoras theorem basically. And so we know that, like, from Pythagoras theorem, if, like, so using these velocities, so if now they give you some velocity, okay, in this case you can find out these angles. So this is 40, 30, 50, so it is basically this angle is 53 degree, this angle is 37 degree. You should know this triangle, which is basically 648 or 345 triangle, okay. So from this you we know the angle, okay. So in this case the rain was falling vertically. Again, same case, rain is falling vertically, okay. Then person A starts running at velocity running, and velocity of rain with respect to A is 10 meter per second, okay. So basically they have given relative velocity of rain with respect to that person. So let's say this is velocity of rain VR. Let's say this is velocity of person VA, and they have given us this velocity, which is VRA, velocity of rain with respect to person, that is equal to 10 meter per second. So for this triangle, they have given hypotenuse equal to 10 meter per second. And one more thing, the this relative velocity is making angle 45 degree. So okay, I should have mentioned it is making 45 degree with vertical or horizontal, but when the angle given is 45 degree, this is, like, you can, like, this will be also 45, this will be also 45. You know that if this is considered as a triangle, okay, or if this, if the we know that the angle between horizontal and vertical is 90, so if they have mentioned 45, it can be any 45. So for this triangle 45, 45, 90, we know that opposite, like, sides apart from hypotenuse are equal. So first thing which you have got from here is VR is equal to VA in terms of magnitude, okay. Of course they have different directions, so their magnitude is equal. So if we have to find out V relative velocity of rain relative to person, it will be square root of VR square plus square root of VA square. Okay. Now since VA and VR are same, we can write it is equal to 2 VR square, square root of 2 VR square. So VR will come out and it is square root will remain as it is. So V magnitude of VRA is basically VR2 VR, sorry, velocity of rain VR into square root 2. So it is 10 is equal to VR root 2. So VR is 10 upon root 2. And since magnitude of VR is same as magnitude of person velocity of person A, so both VR and VR are equal, and it is equal to 10 upon root. Any doubt, or you understood that? Like why it is 10 upon root 2, both velocity of rain as well as velocity of person. Alka, do you have any doubt or you understood that? Clear. Okay, fine. So now we'll say last, like same thing. We'll see similar thing. Like we'll say 2D. We'll see 2D problem for boat and river case, and then we'll stop. So now till now we have seen river and boat problem. So we have seen a downstream case, downstream and upstream case. So we know that downstream is basically in the direction of flow, and upstream is basically in the direction opposite to the flow. So, and in the above cases, whatever we have seen, the boat was either moving in direction of the flow, which was downstream, or opposite direction of the flow. But we have not seen a case where river is flowing like this in this direction and boat is moving in this direction, crossing the river. So now we will see like how it works. Okay. So let's say we have a river. Okay. This river is flowing in, let's say, this direction. So they will either give problem where boat is crossing the river or person is crossing a river by swimming. So let's consider a case of a boat crossing a river. So here is a boat. So in this case, let's say this is the breadth, uh, or basically let's say width of a river. Let's say W, it is width of a river. So if this is the direction of flow of river, so it is, let's say, VR is the direction velocity of the river flow, and W is the width of a river. So if this boat is moving at some velocity, let's say VB, and if this is moving perpendicular to the boat, then if we have to find out time taken by this boat to travel or cross this river will be, it will be equal to T equal to distance, that is width of a river, divided by velocity of a boat. Okay. However, let's say, so in this case, this boat is moving perpendicular to the direction of flow. Okay. So VB and VR are, so of course this VB will play a role in crossing the river, and therefore you can simply write time taken by boat will equal to the length of the, or basically distance traveled, that is width of a river, divided by velocity of a boat. Whereas if you see a case, okay, again let's say VR is the velocity of a river, and let's say you consider a case where VB is in this direction. Let's say it is making angles, some angle theta, and again the distance of or width is given as W of a river. Then time taken by this boat to cross this river will depend on the, like in this case VB cos theta is horizontal component of velocity of boat, then VB sin theta is vertical component of velocity of boat, and the time taken by boat to travel or cross this river will be T equal to W upon VB sin theta. So here in this case, vertical component of velocity of this boat will play a role. Okay. So in earlier case we have seen thing. So if VR is the, if VR is the uh, velocity of flow of the river, and let's say VB was the velocity of the boat. Then net velocity of a boat is equal to velocity of boat plus velocity of river. Okay, we have seen that in downstream case, and in upstream case it was VB minus VR. Okay, in upstream case. So here, let's say this is again, let's consider this is a river. This velocity is velocity of a river VR. So if boat starts moving in this direction, initial velocity VB, or okay, then although this boat is having initial velocity VB, which is in, let's say, y direction, boat will also move horizontally because uh, since the river is moving in this direction, net velocity of boat in x direction will be VB is 0 in this case, so it will be equal to velocity of a river. So so boat will not just go to this point when the river is flowing, it will move away from the this point. Okay, it will go to this point because it is net velocity of boat in the direction of flow is there, which is equal to velocity of river. So boat, if it starts moving, like if the initial velocity of boat is in only in y direction, of course this river will add x component of velocity and make sure that the boat will reach at some distance away from the its opposite side. So, and this distance is known as drift. So this is also important thing. Okay, so we'll see some question on this concept. Okay, so that it will be clear to you. So, okay. So the question is, a man can swim with speed. So instead of boat, we are taking a man. Okay. Everything will remain same. Speed 4 kilometer per hour in still water. So when there is no flow, the man swims at 4 kilometer per hour, and it is basically absolute speed of that man. So how long does it take to cross a river which is 1 kilometer wide if river flow steadily at 3 kilometer per hour? And he makes his stroke normal to the river current. how far does the river, how far does the he go? Okay, 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 okay. So he makes his stroke normal to the river current. So how far does he go when he reaches other bank? So this question cover like most of the thing other when he reaches other bank. Okay. So now let's say a man can swim with speed 4 kilometer per hour. So let's say if we write the velocity of man as a 4 kilometer per hour. So it is like in still water basically. So this is the velocity of river, and let's say it is given as 3 kilometer per hour. No, so man is standing at this point. Okay. So they are telling us the start is motion normal to the direction of flow. So normal means perpendicular. So this width of this river is given as, first of all, it is given as 1 kilometer. Okay. Width of this river is 1 kilometer. And he starts at 4 kilometer per hour normal to the flow. So now we have to find out time to reach, let's say this point is A. So time to reach point B, or basically this other bank of river time. Okay. Okay, so basically they are asking us the time taken by this person to reach this. This is the other bank of river, right? So what is the time taken by this person? So of course we know that initial velocity of this man is in vertical direction, and this is the only velocity which matter for crossing the like river. So if this is a 4 kilometer per hour, and we know that distance or time is equal to distance upon velocity. So it is distance is 1 kilometer divided by speed is like 4 kilometer per hour. So basically 0.25 kilometer per hour. It is his, sorry, 1 upon 4. Sorry, this is D is 1 kilometer, 4 kilometer per hour. So basically 0.25 hours. So he will take 0.25 hours for reaching from point on one bank to another bank of this river. Okay. Whereas now they are asking us to find like how much distance it will cross. So initial velocity was in normal direction, but we know that since river is adding x component of velocity to this man will go like this, and he will reach at some point this point. So we have seen that this is known as a drift. So they are asking us to find us how much is the drift, how much distance that man has traveled from like it's his initially target, because he was targeting to reach this point. Okay, so if we have to find out this distance, now we know that uh, time taken by this man, like timing, total timing of swimming, total timing of swimming. So it is what we got is 2.0.25 hour, because for reaching from this bank to another bank he took 2.0.25 hours, basically 0.25 hours. So and x component of velocity is basically the 3 kilometer per hour, which is velocity of river. So distance cover will be velocity into time. So velocity in x direction is 3 kilometer per hour, and time he has traveled is basically 1 by 4 kilometer, sorry, 1 by 4 hour. So our hour will get cancelled, we will get 3 by 4 kilometer. So this distance is drift is basically 3 by 4 kilometer, and time taken for the by this man to travel from one bank to another bank is basically 0.25 hour or 1 by 4 hour. Yeah. Any doubt in this question? Because this one question cover up almost this concept. So any doubt, please write yes or no, so I can. Okay, you, Alka, do you have any doubt? Can you ask if you have? Okay, okay, fine, okay. So now we will see the last question for today. Again, let's say there is a river, and this like velocity of a river is basically 10 meter per second in this direction. Okay. Now, so this is, let's say, vertical. So a man starts swimming at 10 meter per second in this direction, which is making angle 37 degree with vertical. Okay. So now we have to find out the drift. So like whether if we lands here, then how much is this distance, or if we land at some this point, then how much is this distance. So we have to find out drift. So at what distance, means basically how much distance from this point, vertical point, he will move. Okay. So this is the point which is exactly in front of his initial position. So what will be his final position from this point? Okay. So that we have to find out. Let's say his initial position is A. So for this river, the initial like the position in exactly opposite to its initial position, let's say, is B. So we have to find out his final position or distance from B. Okay. So his velocity is given as 10 meter per second, which is making 37 degree with this vertical. So we can divide this velocity component in x and y direction. So velocity in x direction will be basically 10 sine 37, and in upward direction it will be 10 cos 37. So the man's velocity will be like sine 37 is 6, so it will be 6 meter per second, and this is basically 10 meter per second. Okay. So first of all, we will find out the time taken by this man to reach another opposite bank of the river. Okay. So for that, like we know that it will be this. Okay. So I forgot to mention that this distance is 100 meter. The width of this river is 100 meter. So we know that time or timing of swimming or time taken by this man to swim, total timing of swimming is basically time is equal to distance upon velocity. And we know that, sorry, 10 cos 37 is 8 meter per second. Okay. So we know that distance, like if we have to find out this vertical or the time taken to cross this river, then this vertical component of velocity will matter for us. So it will be d upon basically 10 cos 37, which is 8 we have already got. So it will be 100 upon 8. So that will be 12.5 seconds. So he takes 12.5 seconds to cross the rivers. Okay. And this is the total timing of swimming. Now we have to find out x, or so net velocity in x direction. So net velocity in x direction is basically it is velocity of river plus velocity of that man in x direction. So velocity of river is 10 and velocity of that man is minus 6. So minus 6 because this is in negative x direction, whereas velocity of river is in positive x direction. So what we got is 4 meter per second net velocity in x direction. So instead of, since velocity of river is 10 meter per second in this positive x direction, this man, even though he is having initial velocity in this direction, he will go like this. Okay. So finally, what we will get is, uh, so we have to find out this distance. So distance in x direction will be net velocity in x direction into time of swimming. So it is 4 into 12.5. So that is equal to 50 meters. So this man will reach at 50 meters from his initial position, or from this point B. Okay. Again, any question in this concept? Okay. Okay, so if both of you are not having any question, mm, okay, then I think we can meet tomorrow at 5 p.m. We will stop for today. Thank you so much for joining.